Hey everybody, this is Larry. This is me going with day 27 of the July Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So I'm in sunny San Diego, as I've said. So yeah, some things are a little bit uh, just having, you know, being remote. So yeah, so today's problem is going to be the three sum closest. I usually start this live, so if it's a little bit slow, fast forward, watch on 2x, whatever you need to do. Okay, so giving away nums and then integer target. Find between such that the sum is okay. Then the sum of the three integers. Okay. So this is 1,000. So there are probably a couple of ways of doing it. A couple of ways of doing it. A lot of it is bookkeeping. So what's running through my mind is that I can do well. N cube is going to be too slow. It's the obvious solution, the naive solution, but it's going to be too slow. And I think about okay, n squared log n. What does that look like? Is that fast enough? And what kind of edge cases do you do so that you don't have duplicate situation? And then the last one is I guess that's also n squared log n, but technically n squared log n squared, but it becomes n squared log n, and I'm still thinking about that as well. Um, I think it doesn't. I think it should be okay either way, but yeah. Let's see. Yeah, well, I think it should be okay. We just have to think about. Yeah, I think I'm just going to do the n squared log n one. Given that n is equal to 1,000, and that should be fast enough. If not, then we'll play around some more. The log n comes from binary search, as you may guess if you have some practice. The tricky thing is that we need the sum closest to target. So that means that that means that it actually is trickier than or complexly trickier than exact, because in this case you want to be able to kind of look at adjacent elements, which is where binary search comes into play. So here, I think now then the loops really we have to figure out how the loops go. The way that I think about it is okay. There's I, j, and k for num sub I, num sub j, and num sub k. That's for this purpose without loss of generality. You do I less than j, I less than j less than k, and here we can do I. Yeah. So then here, there, there are a couple of ways to do it, but I'm going to do it this way where n is equal to length of nums. We can maybe even sort it, but I don't think that. Actually, yeah, let's sort it. I mean, it doesn't matter in the sense that you can do other things about it to keep it sorted, but if we sort in the beginning, it's actually easier. Then now we do for j is in range of n, and then for k is in range of j plus 1n, because because we want to make sure that k is greater than j. And so here what's left is that we have to find I, and from I we can find using a binary search, and I is less than j, so that means that after we process j we can add I to the thing later. So now we just have a pool of things. Let's call it I'm always really bad at naming things. Let's just call it I want to say ice, but it's been weird, so okay, let's just do num ice. Maybe that's okay. And then here at the very end we'll just append num sub j, because now we moved the j, so then now I can be available, right? And here we have num sub j plus num sub k. We're looking for a number that's closest to target, right? So target is, this is not true, but num sub I plus, so this is what we want this to be closest to, right? And so what happens is, of course, you just do some mathematical manipulation and you move this to the other side. by subtracting. So you have this, and that means that given these three things which are now fixed in this loop, we're searching for num sub I. So yeah, so then now we can simply do a binary search on nums i's of this number on the left, right? So here we get the index of the array, and then that means that the closest possible is either, and this is just binary search things. We binary search for the number that's so bisect left gets you the number that is the smallest number that's this number or greater than. So that means that it's always going to be equal to or bigger, right? So you want to get the number that's smaller just in case. So you also have index -1. So yeah, so now you have two numbers. You have the index, and then we just kind of do a best closest to target. Okay, I just want to see what's the tie breaking if there's a tie, and yeah, since it's only one solution, then we should be okay. In returning the sum. So yeah, so let's just say best is equal to some infinity number. Doesn't really matter. So that means that the delta, if absolute value of target minus this thing is smaller than best, then we set, well, it's less than absolute value of best minus target, or target minus best, maybe it's more symmetric. If this is the case, then best is equal to num i's of index. This is a little bit awkward, but it's same idea. And then we also do, as we said, index -1 to check the number that's smaller than this number. And yeah, and there you go. And of course, you have to just do some bound checking as well. So we want to show that index -1 is greater than 0 and all this stuff. And at the very end, we just return best. I think this should be good. And it's n squared log n. Maybe I have some typo though. Oh, I guess index, that's true. Index can also be bigger than all the numbers. So then in this case, you just do. Yep. Again, this is n squared log n. Hopefully this is fast enough. Did I mess this up? Oh, this isn't, I mean, I messed it up. This shouldn't be less than n, is less than nums i's. Yep. Okay. That's an unfortunate answer. The unfortunate part being that is incorrect. Where did I go wrong? I mean, there's only three possible numbers. Okay, let's check this out for a second. Maybe I have a typo somewhere. Why do I even return -1? Also, best cannot be -1. Can it be -1? Well, oh, I messed up somewhere. So yeah, this is my fault. So yeah, okay. I'm just confusing my variables. What I want to do is, because I'm setting best equals to this number, but this actually thing doesn't make sense. What we want is target minus this minus nums minus j, right? I think I was confusing this for another problem. But yeah, you have this minus the best, and best should be the sum of I, j, and k. Best should contain sum of the best possible num sub I plus num sub j plus num sub k. I think I'm skipping ahead too fast and I'm confusing things. But yeah, but in this case, then you should be able to set best is equal to this amount. And same thing for here, except for index -1. A little bit copy and paste magic. And this should be good. I wish they had more examples, but we can also just construct some, so it's not a big deal. Okay, so I mean, I'm relatively confident about this. The only thing that I might worry about is, whoops. The only thing I might worry about is, what was I going to say? Is that this may not be fast enough because this is n squared log n, and n is a million. Oh, sorry, n squared is a million, and log n is like 10, so it's like 10 million. Which for Python is a little bit slow on LeetCode, so especially since it does a sum of execution. But anyway, that is said, let's give this submit and give it a little bit of YOLO, and it looks good. Accept it. Yeah. So as I said, this is going to be n squared. And the binary search will make it log n, and that's pretty much it. The thing to keep track of here, and there are a lot of things to, even if you have the idea right about binary search and stuff like that, is that there can be a lot of there are a lot of places you can get it wrong. There are a lot of edge cases if you're not careful and so forth. And that's where I didn't articulate this well enough in the moment, but that's what I was thinking about. And what I was thinking about is that, okay, how do we make sure that we hold and hold this in this case, right? Because if we are able to hold this case, we are able to hold this invariant, then we don't have to worry about duplicate entries. Because you can imagine that, for example, in this case, if you use, well, maybe not in this case, but if you can imagine that you try to use the same number twice, and that's a really bad edge case. So it leads to sad things, right, and sad times. But if you're able to kind of keep this loop of I that's less than j less than k, then you're good. It means that all the numbers are unique because they cannot equal to each other. And that's basically the idea that I have here, and that's why I labeled my loops this way and try to figure it out on the other ones. But yeah, that's all I have for today. Let me know what you think. Hit the like button, hit the subscribe, and join me on Discord. Stay good, stay cool, stay healthy. Have a great rest of the week. Bye bye.